Hey, welcome back everyone. So now that we have our Track Buddy board components all soldered together and hopefully working, we're going to flash our firmware. So we're going to first test to make sure that all the boards work, and then we will go through the Mark II firmware. We're actually going to build the Mark II firmware and flash it and then take a look at it and make sure that all our components work before we move into 3D printing our enclosure. Now, if you've never worked with Arduino before, or this is you have never used it and developed with it, we're going to need some software first to install on our computer. The first piece is the Arduino Ide, so you can download it here at the arduino.cc, and then if you click on the software tab here, you can download the latest and greatest software. So I actually have 1.8.15 at the time of recording. It's the most recent. Feel free to take whatever is recent at the time. It should work out of the box, and we can go from there. The second piece of software that we're going to need for the firmware is the Arduino Joystick library. So this is a really cool piece of software, and I will put it in the description. And what it does is it allows us to let Windows think that our Arduino is a normal joystick. I've used this in the past for building things like button boards. I even built like a replica of an F16 throttle. And it basically it seamlessly integrates with Windows to say, okay, these are the buttons, these are the axes, and we go from there. So what we ultimately do with Track Buddy is put that yaw, pitch, and roll into joystick axes, and then push that into software like OpenTrack, which we'll get into in the configuration piece. But it really makes this whole process so much simpler. So in order to get this, we're going to go into the releases. We're going to select our releases here, and then you're going to download the zip. Now, I've already downloaded it, and we'll go through the installation with that. But once you've downloaded and installed the Arduino software, and then you've downloaded this zip, go ahead and boot into the IDE. Now, when you boot it up, it's going to look a little bit like this. Now, there's two things that we're going to need to do in here. First is we're going to install that zip file that you just downloaded. To do that, we're actually going to go into Sketch, include library, and then add zip library. And so you'll navigate to wherever you downloaded it. So I downloaded mine in Downloads. You'll select it and click Open. Now I've already done that, so I'm not going to click Open. But once you do that, you can check to see if it's installed by going into File, Examples, and then you should see Joystick down here under this Examples from Custom Libraries. Now, the other thing that we're going to need to download is we need to install the SparkFun BNO080 library. So if we go to Manage Libraries, it'll bring up a dialog box. It'll take a second to, update and populate this list, and just type in BNO080, hit enter, and it'll take a second, but it'll load up the SparkFun BNO080 Cortex-based IMU. You're going to want to select this and click install here. Now, I've already installed it, so it's not going to let me reinstall it. But once you've installed this, with this in the joystick library, you should have everything you need so that we can start this. Now, the first thing that we're going to want to do before we try to flash firmware, before we want to go nuts, is we want to go in and we're going to go to our examples under File. We're going to go down to the SparkFun BNO080 Cortex-based IMU, and we're just going to select one of these examples. I'll do the Euler angles because it's going to be very similar to what we're actually going to use these to do our Track Buddy. So once we've done this, we're going to plug in our Pro Micro. So give it a second. You should hear Windows come up. Go into Tools, select Port. Make sure that you have a port selected. Now, the board that I have is an Arduino Leonardo, and the Pro Micro will show up like that. I don't know what board you're using. If you are using the Pro Micro and it is like a Leonardo type board, but you don't see board here, maybe it says like Uno or something else, just go into this AVR boards and then go through the drop down and select Leonardo. Now, once you've done that, we're actually going to do we're going to basically click verify here. Make sure that we don't have any errors. We shouldn't, because this should be perfect. We didn't. Great. Now we're going to click upload. Now this is going to upload some information into our Arduino. We're going to go to Tools, Serial Monitor, and then make sure that you have readout, right? So this means that I didn't screw things up for once. It means that we put all the wires in the right place. The BNO is the BNO 080 is recognized and is sending data to our Arduino. If you see something that says like BNO not detected, that probably means that you didn't put the wires in the right place. I've also had it so that if it's not detected or it's not working right, it just won't show any output. So if you do get into a situation where you have no output, this is just a giant blank screen, do check that you actually wired everything the way that you thought you were supposed to. It could also mean that you have bad boards. So there may be some level of troubleshooting, but if you get numbers and they're populating as I move the board around, it's changing the different numbers. That's a good sign. So we can go ahead and close this now, and we can go ahead and close this sketch because we're not going to use it. The next thing that we're going to do is I'm going to open up the Track Buddy Mk2 firmware, and we're actually going to turn this into the Mk2 firmware, and that'll give us an opportunity to kind of walk through what we've done. So we'll save as, and we'll put this on like the desktop, and we'll call this Mk2. This will be in GitHub, so there's no real reason that you'll need to go through and code this yourself. But I figure it gives you an opportunity to kind of understand what we're doing. Now, that being said, if all you're interested in doing is flashing it, I'll put in a tag to skip ahead, but we'll go ahead and take a look at the software now. So, like I said, we're pretending that this is a joystick, and in order to do that, we are using the joystick library as well as the library for the BNO 080. Now, I also said that previously the Track Buddy only had one button, and that was for basically tearing it. So when maybe you had some drift or whatever else, you push the button and then it made sure that everything was set back to 000 with some sort of an offset. Now, one of the issues that we want to address is being able to pause our head tracking on demand, so that we can record external views of our flight, with our DCS or any other software that might take that head tracking input and move the camera around for external views. So in order to do that, we're going to have to define a couple of things here. So we've already gotten our joystick library, our wire, and the SparkFun library. We already have a tear button. We're also going to need to define, our pause button. And I'm going to set it to 8 because, as I said previously, the pin 9 was burned out on a different project. I'm not always the most clever with soldering, and so I kind of made a boo-boo, but the board still works great. All right, so moving on. We're going to need a couple other things here. So we already have a tear state. We've got an x-axis, a y-axis, a z, or our z-axis. We are going to need a current. We're going to add a current tar state here. We are going to add a current pause state. And we are going to add, we've got our last tar state, we've got our current tar state. We have a current pause state, which we're not going to populate with the value. We need a last pause state. We're going to assign that to low. And then we need to be able to check when there's an unsteady state, right? So like when I push down on the button and that's changed, we need to have that that state defined as well. So we're going to call this like the last change. So CHG state. And we'll set that to low as well. So one of the things that we're going to want to think about with this particularly is that, you know, when we push this button for a tear, it's fine if we don't have debouncing, right? Like it's totally okay if it keeps going back to 0, 0, 0, 0, 0 as you're pushing down and then letting go of that button. With a pause, we want to make sure that when we push down on it, if we, you know, the CPU is very fast, so we want to make sure when we push down on it, we don't get like 7 or 8 registers at once, because otherwise we'll run into a situation where when we try to unpause it, you know, maybe it does like 8 and then it actually didn't pause it, or maybe it does 7, so it didn't actually unpause it, and then it could cause issues. So we're going to put in some basic debouncing in here. Nothing fancy. Totally can find this code probably all over the internet. It's not really, you know, anything super cool or novel, but we definitely are going to need it here. So in terms of other things that we're going to need in here, we are going to need some floats. We're going to, because I'm going to change some scope, we're going to add roll out here. So if you looked at the Mark 1, I actually am defining this inside of the loop. But out here, I think, is probably better because we are going to have to pause it, which means we're going to have to, you know, go kind of inside for scope. So we'll put in the yaw as well. All right, excellent. So now we've got our yaw pitch, and then I'm also going to put in our offset, and I'm going to save you from having to watch me completely type all this stuff out. So we'll just paste that in. So we're going to add an X offset, a Y offset, and an RZ offset. So these were originally, you know, at the loop, but we're going to bring them outside of the loop just so that we have, you know, a little bit more control. Then we'll make sure that these are all the same too. Here, all these ints. Get rid of these. Awesome. So now we are going to need something to track the state, because we haven't done that yet. So we're going to add a Boolean, and we're just going to call it paused. And we're going to start with false, because we don't, you know, we're not going to go out of our way to start with paused. If you wanted to, you totally can. So if you want to change that, like for personal preference, go for it. The other thing that we're going to do is, because we're doing a debouncing and I don't want to delay my entire loop, we're going to put in like a little basic timer here to track the milliseconds. And so we're going to put an unsigned long in here. And this is going to be, this last pause debounce time is going to be basically how long that you're holding down the button. So if you click it, you know, if it's 50 milliseconds, 100 milliseconds, whatever, it's going to help us understand, you know, if you meet a certain threshold, then we will say that you push the button. If you don't meet that threshold, you know, you'll be fine. You won't be accidentally triggering something. So the other thing that we're going to do is we're going to move these Booleans up, right? So I'm just going to go ahead and delete all of this out of here, and then we'll just put in the new stuff and talk about it. So after the unsigned, we have a couple of other Booleans. One is for debug. This is just to let us have the serial monitor. You can totally turn this off when it goes into production if you want. I'll probably update the GitHub so that this is defaulted to false. But for now, because we're actually testing something, we're going to leave it to true, just so that I have some way of saying like, yeah, it's actually doing what I think it's doing. The next thing is this init auto send state. This is part of the joystick library. We're going to set this to false, just so that we have to manually send the state. If you say true, then at the end of every loop, it's going to just update things. I think it's at the end of every loop. I'd have to double check, so don't quote me on that. But basically what it'll do is either the joystick library will take care of this, or we have a send state that says, okay, you know, at the end of my loop, I say, okay, here's my joystick. All my joystick axes have been set. Please send this now to the computer. The next things that we have in here, smoothing. So what we end up with is the degrees for our yaw, pitch, and roll from 0 to I think it's negative 180 to 180. And we need to convert that into a straight up integer that we can use to send to Windows. And so this is going to be part of that mapping process. Next is debouncing and send rate. So send rate is going to take a look at how fast we're sending in milliseconds stuff from our IMU. And then debouncing is I've added a delay at the bottom of the loop to give you an opportunity to say, hey, you know, I don't want it, you know, every iteration, I don't want it just, you know, constantly sending something at that speed. Maybe I want to delay it a little bit. I've personally found that the debounce piece isn't really necessary. I just put it in here because, again, I'm a tinkerer. I'm still playing with this. I'm definitely not going to like sell this code or this whole thing. It's just to kind of play around with and see what you prefer. And then the pause debounce time, this is the amount of time that you, in milliseconds, that we're going to have to hold down that button in order for it to trigger. All right, so that's kind of our big constants and different variables that we're going to use in this. The next thing is we need to initiate our joystick class here. So when you're using the joystick library, it's very extensible, right? There's a lot of things that you can do here. You can have a bunch of buttons. You can have, what is this? A bunch of axes. So X, Y, Z, and then rotation around X, Y, Z, a rudder, a throttle, acceleration. So like an accelerator, a brake, and steering. So there's a ton of axes that you can put in here. Now for this, we're only going to put in 3. So we have X, Y, and then RZ. And then everything else is just set to false or 0, right? We're not using a hat. We're not using any buttons. So that's all set up and ready to go. All right, the other thing that we're doing is we're going to initiate our BNL, right? Got to do that. That's pretty standard stuff. This just makes sure that we're able to use our chip that we put in there. Now, this other stuff's pretty straightforward. We've got the debug piece here. This is just going to establish. So let's back up a second. So void setup. This is basically our setup. You know, as the chip is booting up and getting ready to go, our Arduino is, you know, initializing itself. It's going to run through this. So this is where we're instantiating things. We're starting our joystick. We're saying, okay, our pins are doing different things, which means that we also need to add our pause button here, right? Because we only had the tear. So now we have pause and tear. And then here we have the debug. So if you say debug is true, then it's going to start, you know, it's going to spin up the serial. It's going to start allowing you to track things and print things to console, essentially. All right, so that's about it for setup. Setup's really, really simple. Now, this piece. So our first if clause here, I'm gonna add a couple of things in here. That all the way at the bottom? It is. So let's just completely zero out this whole thing, and I will just put in the whole piece here so that you can see it and we can just walk through it together. All right, so for our main loop, so this is the thing that the Arduino is going to be doing over and over again, assuming that our IMU is working. We're going to check to see if we're paused or not. So if we're paused, we're not going to keep getting the values. If we are not paused, we'll continue to grab these values. So the whole idea here is we're not going to stop a delay or basically stop sending data to Windows. What we're doing is we're just going to keep sending the same data. So that's kind of how I've decided to run the pause. If folks have a better idea, I'm all ears. Definitely submit a pull request. I'm very interested in hearing from you. Now, the other thing that we're going to have in here is our offsets. So this was in Mark 1. You know, you push the button to get the tearing done, and it'll just say, okay, yeah, I've created these offsets, and I'm just subtracting them. And so now I'm back at the origin. Again, like I said, we're mapping things, right? So we're going from negative 180 to 180 and then turning it into an integer between 0 and 1023. All right. And then this piece here, we need to set the value to our axes. So we're the joystick library has specific methods that lets us set the values directly to the specific axes, so X, Y, and RZ, which are dependent upon how you instantiated the joystick class above. Next, we're checking to see if we actually pressed tear or not. If we did press tear, then we're going to just go in here and take whatever our current roll, pitch, and yaw is and say, yep, that's how far we're off. And then that's what we're going to subtract from. All right, next is our current pause state. So this is where we say, okay, let's see if we're pushing down on the pause button. If we are pressing the pause button, we end up, we say, okay, is it different than where we were at? If it was, then we start this timer here and we start counting to see, are you holding it for more than 50 milliseconds, or is it, not 50 milliseconds? So we start this timer and we say, okay, our last change state, this state that is transient or flickerable, I guess, we're going to set it so that we can detect if, we're holding that button down or we're not holding it down. And because of how fast the Arduino is running these cycles, this is pretty important, right? So you'd be like, well, I only pushed it for, I just pushed down, I heard it click, and then I let go. There might be 8 to 10 different, registers of, it's one. So that's what we're doing here is we're just saying like, okay, well, we're holding it down, so we need to make sure we're holding it down and detecting if we're holding it down. And then we do a little calculation here to say, all right, well, our timer, yep, we did more than 50 milliseconds. So now, or whatever you set the value to. So now I know that, this is signal, and we need to do some sort of like determination of whether we're pushed down. And, if we're pushed down, then that means I have to flip the bit on paused, right? We need to make it from true to false or false to true, which is what we're doing, right? So if we were high and our current pause state was low, which means that we weren't on anything, with that, and we're pushing the button. So now we need to, we need to pause or we need to unpause. Otherwise, this is commented, so it's not actually doing anything, but you could put in something here if you wanted to say, hey, this is just the normal state of affairs, like we're not being pushed. We can actually just delete that out for this. Next, oops, too many. So next, after we've done that, we need to update our last pause state with our current pause state to make sure that, we kind of complete the circle here. And then I added a couple of debugging statements. So it'll tell us if we're paused or if we're running. If we're, debugged, so we'll have our roll, pitch, and yaw, and then the state. So now we can test this. So we'll hit this button here. Let's compile. We're gonna upload. And then we are going to go into our serial monitor here. Oops. Change the port. It happens to the best of us. Yeah, always check the port. The port sometimes will change arbitrarily on you. All right, so now we have our output here, right? So we see that we're getting yaw, pitch, and roll values. I can, I'm moving it around. It's coming out and it's saying it's running. So the first thing that we're going to test is, can we zero it? So we push the button that's 0. Yeah, it does 0. Totally got it. Now let's test the pause button. So I'm going to push pause. You'll see that we're paused. We're running. So that we're going to have to take a quick peek at. So let's take a look here a second. Yeah. I made a copy and paste error. That's always a bummer. I apologize for that. Very good at copy and paste error. So anyways, if we get rid of this piece here, let's double check that. Shouldn't have been it, but with my luck, you never know. Tear, pause. Ooh, it's a tear issue. That is exciting. What happens if I unpause it? Does it go back? It does go back. So we start at 0, right? So 0, I'm not going to move it. It's going up crazy. Huh. That is interesting. So let's take a look at that. So when we change tear, okay. You know what? Let's put this, the tear piece, let's put it inside the paused. You know, I'm thinking that I kind of like that idea anyway, because if you're paused, you're not gonna need to tear, and I don't want to accidentally tear when I'm paused. Let's see if that fixes it. Okay, so let's tear it and pause it. Huh. That is really interesting. All right, well, I'm gonna have to investigate this and I will get back to you. So I'm back and I realized what it was about 5 seconds after I hit pause, or I guess stop recording. So it's because I'm constantly subtracting the offset. So so this needs to go up there. So when we're doing the correction to determine whether or not we're tearing, that is causing havoc because we're just constantly subtracting things, right? So the numbers are just going to go deeper and deeper into negative until they roll over. So we're just going to make a quick change here. We're going to try this. Make sure we select the right port because apparently it's changed on us. Cool, we're in the right port. We're going to take a look at serial monitor. All right, so we're going to tear it. We're going to get that offset, which means that this hopefully won't immediately go down into the negative gazillions. Yep, looks better. Push the button, back, tearing, pause it, paused, unpaused, paused, unpaused, paused. Awesome. So it looks like we're all set now. So I apologize for that, but it's always fun to find some fun bugs when you're doing some of this stuff. So this is it for this. Once we've done this, we've essentially flashed our Track Buddy. We're set to move on to the next piece. However, I am going to show one additional thing that we can do. So one of the things that you may notice is that the name of so if we go into the USB controllers, so you can see my, my gunfighter, and then you see Arduino Leonardo, right? So the issue you'll run into is if you start using the joystick library a lot with a lot of different things, this will always be, I guess, conflicting, right? So if you don't do anything, it will conflict, and it will cause pain and suffering, potentially, because you can only have one attached. Now, that being said, there are videos on YouTube that show you how to change the name and essentially the address for the USB. I did include in the repository it's basically a replacement for the boards.txt that allows you to override the essentially the Arduino Leonardo. It allows you to set that USB, and then it'll call itself Track Buddy. Now, so if we go and take a look, actually this is in, so fun fact, the ARM-based boards, they are in your app data, and then the standard boards, like the Pro Micro Leonardo, they are actually in program files x86, Arduino, then I believe it is in hardware, Arduino, AVR, and then boards. So if we take a look at this, you'll see all of these different pieces. You'll have like the VID, PIDs. And so if we go down and we look at Arduino Leonardo, there's ETH, Arduino Leonardo, we can actually copy this information. And so I'm going to open up the other boards piece here. I believe this one has the Track Buddy piece in it. And basically all I'm doing is overriding, yeah, so here's Track Buddy. I'm overriding it and assigning it a different build VID and PID. Now you do want to be careful with this. It may not be the best practice because if you inadvertently select a VID or a PID that you're already using on your computer, you could potentially have a confliction and it won't do things. I've just been kind of incrementing them through different, Arduino boards that I'm not going to probably ever buy or use. And it's unlikely that I'm, plugging in all my button boxes and what have you when I'm also doing a bunch of Arduino stuff. So your mileage may vary. Just be aware that when you do this, it's something to be considering when you're looking at it. So what we're going to do here quickly is we're just going to copy in this information. I do want my Track Buddy to say Track Buddy. We are going to, I think I have to overwrite it too because it's in program files, which is always annoying. So what we're going to do is we're just going to pop it in there. Actually, I don't even need to do that. We'll just do this. We can just rename this ports.old. And then, yeah. Yes, you can. And yeah, you will need administrator access to do this if you're going to do this. Just call this boards. Yep. I don't care. All right, we're going to close this all out real quick. We'll open back up this. So what we can do here is we can actually open recent Mark II. Excellent. And then we can go in and make sure that we have the Track Buddy board. Now, because this was already basically a Leonardo, it did recognize that it's a Leonardo, and because I put it after the Arduino Leonardo, it's going to supersede it. So now you're not going to see Arduino Leonardo in here. You're going to see Track Buddy because I basically have overwritten it. I don't keep it that way. I just do that for Track Buddy. All right, so there we go. And then we can go ahead and upload this. Same code that we were already using. Now, if we go back to our game controllers, USB game controllers, we can see that we have Track Buddy. All right, so that's it for this video. And in the next video, I'll quickly walk through the 3D printing piece of this. All right, till next time.